Welcome to University Davangere. I am Anil Kumar TRB, Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to study the experiment number 3, that is the VI characteristics of TRIAC. Experiment number 3, that is VI characteristics of TRIAC. Contents: aim of the experiment, theory, apparatus required, circuit diagram, procedure, calculations, results, graph. Aim is to obtain the forward and reverse conduction characteristics of TRIAC and plot the characteristics curve. Theory: the SCR is a unidirectional device as it conducts from the anode to cathode only and not from the cathode to anode. A TRIAC can conduct in both the directions. A TRIAC is a bidirectional thyristor with 3 terminals. It is used extensively for control of power in AC circuits when in operations. A TRIAC is equivalent to 2 SCR connected in anti-parallel. As a TRIAC can obtained in both the directions. The term anode and cathode are not applicable to TRIAC. Its 3 terminals are usually designated as MT1, the main terminal 1, and MT2, main terminal 2, and gate. So this is the actual circuit diagram. This is our TRIAC which is connected in two anti-parallel SCR, that is MT2 and MT1, and this is the gate terminals. So for this we have to see the characteristics. We are giving a supply of 12 volt DC supply to the gate terminals, and we have the MT2 and MT2 terminals. We have the supply from the 30 volt DC supply, and we have the port 4 and port 3 for the varying the value of R. So apparatus required: SCR study module, ammeter, voltmeter, and connecting wires. Procedure: connect the circuit as shown in circuit diagrams. Connect MT2 terminals of the TRIAC to positive with respect to the MT1 with positive gate current. Switch on the main AC supply. Vary the port 3 and set the gate current to 12 mA to 15 mA. Slowly increase the VK by varying the port 4 till the TRIAC gets turned on. Note down the ammeter and voltmeter readings. Note down the forward breakdown voltage. Further increase the VK and note down the current. Now tabulate the readings, plot the graph VK versus IA current. Connect the MT2 terminals of the TRIAC to the negative with respect to the MT1 with positive gate current. Repeat the procedure from step 3 to step 9. This is the forward conduction mode, that is a VT2. We have taken 5 volts 0 current, and 10 volts it is 0, 20 it is 0, for 0.7 20 milliamperes, for 0.7 70, 0.7 is 81. For this is reverse conduction mode. These are the readings we have got, and this is VI characteristics of the TRIAC. So this is the forward conduction mode, and this is the reverse conduction mode. At the breakover voltage, the current is going to be rise. Once the breakover occurs, the anode current start rising. So this TRIAC is in the on condition during the terminal, when the terminal is positive, and this is the reverse conduction mode. Result: thus the forward and reverse conduction characteristics of TRIAC are obtained and they are plotted. So let us see the real time of the experiment, how the TRIAC will work experimentally. Hello, I am Anil Kumar TRB, Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to study the VI characteristics of TRIAC. So this is the TRIAC unit. We need to turn on the unit first. So once we turn on the unit, we have to keep the gate resistance and the anode resistance at the minimum position. Okay, after setting the gate resistance and anode resistance in minimum positions, we need to keep the voltage, that is MT2 and MT1 of the TRIAC. So this is MT2 and MT1. So MT2 and MT1 voltage should be kept at the 10 voltage. We need to set the MT2 MT1 voltage for 10 volt. So after setting the 10 voltage, we need to turn on the VG, that is the gate voltage supply. So we need to observe what is the gate current, at what value of the gate current the device will goes to on conditions. We need to set the gate current first. So it is 2.2, it is 10. So 4.5, it is 10. 4.5, it is going to be reduced. So 5.6. So 5.6 is our gate current. That is 5.6 milliampere is the gate current. So now we have to reduce MT2, MT1 voltage back to 0. Then to off this. Then again we need to turn on. Then increase the value of MT2, MT1. Now we have to increase the MT2, MT1 voltage from 0 to maximum value. Let us see at what value of anode current will comes. So 3.3, it is 0. So 6.6, it is 0.
Okay, we need to tabulate the MT2 and MT1 voltage versus the anode current.